Hi ladies, this is Mrs. Blofus here. And in this lesson 5.6, we're looking at making scatter plots, and we're going to write equations that model the data that we're given. So when we have a scatter plot is a graph, and it's composed of a bunch of different points on there. So it's related to paired data, so like an x coordinate and a y coordinate. And we use that just to determine whether or not there's a trend or some kind of relationship between those two data points. A correlation is the relationship that we might see within a scatter plot. So it's the relationship between two sets of data. So as we get closer to winter, let's think about the correlation between dropping temperatures and the demand for winter coats or sweaters or scarves or things like that. You'll see like in Target, all their sweaters and scarves are out, their swimsuits are put away. And then lastly, the line of fit. And the line of fit is a model that we're going to use to represent the trend of the data. So it could have a positive slope or it could have a negative slope, just depending on the correlation of our data sets. In this, oh, let's see, I skipped a part. When we talk about correlation, so this correlation is like our slope. So as x increases, so remember we read a line to determine the slope from left to right. So as x increases, what is happening to the y? And if our slope is positive, so if we have a positive correlation, that means that y goes up as x goes up. So that paired data has a positive correlation. If we have a negative correlation, or if our slope of our best fit line is negative, then as x increases, so again, we're reading from left to right, as x increases, y decreases. And if based on the scatter plot, you can't tell what the trend is, the points are kind of all over the place and there doesn't appear to be any relationship, then there's relatively no correlation. So let's look at a couple of examples here. So we'll look at example 1, and you can see how as x increases, what's happening to our y values? Are they increasing? Are they decreasing? Or do they appear to not be correlated at all? I could draw a line here. And if I draw a line that is pretty close to all of those data points, my line is going down from left to right. Okay, so as my x values are increasing, my y values are decreasing, and that tells me that I have a negative correlation. Now, if I look at the second graph, in graph B, my first coordinate, the y is pretty high, the x is low, but in my second point, my x is getting higher, but my y dropped way down. And then it goes up, and then it goes down, and then it goes up, and then it goes down. They're kind of all over the place. So I don't see, I could draw a line either way, and it would be just as close to all of the other points. So if I draw a line like this, these couple points are kind of way off of it. But if I drew a line like this, I still have a couple points that are kind of outliers. So these points are not really close to it. So if I can draw a line both ways, or if I can't draw a line at all, then I am going to say that this has relatively no correlation. All right, let's look at the second example. And in the second example, we're making a scatter plot of the data. And so I have x values, I have y values. I'm going to go ahead and plot those points. And you can do this on your own paper as well. Okay, so I have the point 1, 3. I have the point 1.5, 1, 2, 1, 2, negative 0.5, 3, negative 1, 3.5, negative 0.5, and 4, negative 2. So let's just look at these points. And by looking at this, I could draw a line that's pretty close to all of them. And the line that I draw is going to end up going down from left to right. When you draw a line of best fit, you want it to be as close to all of the points as possible. So first thing I did was I graphed all of those as ordered pairs. So I plotted the ordered pairs as points in the coordinate plane. And then I sketched in a line, and I just sketched it in. I just looked at it and tried to make that line as close to all of the points as possible. And when I did that, I could see that the correlation between the data sets, the X and the Y pairs, are negative. So that next box that you see on your notes talks about using a line to fit the data model. So when we do this, we're going to do it just like we did in that last example. We're going to first make a scatter plot of the data. And once we make a scatter plot, we're going to decide whether the data can be modeled by a line. If there's no correlation or relatively no correlation, then we're not going to draw a line in. If it looks like a parabola, we're not going to draw a straight line. We'll have to use a different model for that. Right now, we're just working with linear equations. And then the third step would be to draw a line that appears to fit the data closely. There should be approximately as many points above the line as there are below it. And then my last step would be to write an equation using 2 points that are on the line, not 2 points that are in my data set. So not 2 points necessarily that are plotted, but 2 points that are on the line. They have to lie on the line that best fits the data set. So just to reiterate, they do not represent the actual data pairs. They have to lie on the line that we sketched. All right, let's look at example number 3. In example number 3, we're writing an equation to model the data. So in the last lessons, we looked at writing equations of lines that go through specific points. That's what we're doing here. So it says that the table shows the average attendance at a school's varsity basketball games for various years. We need to write an equation that models the average attendance at a varsity basketball game as a function of the number of years since 2000. First thing we want to do is make a scatter plot. So notice our x-axis is years since 2000. So in the year 2000, our x-coordinate wouldn't be 2000, it would actually be 0, because the year 2000 is 0 years since 2000. In 2001, we have 1 year since 2000. Then 2 years since 2000, 3 years, 4 years, and so on. Okay, so X is the number of years since 2000. Okay, so first let's go ahead and we can plot all these points. Do the best you can. Sometimes when you plot these by hand, they're not quite exact, and I don't expect them to be, so just do the best you can. Okay, so here's what my data looks like. If you haven't finished, just pause the video and finish plotting your points. All right, the next step is to decide whether the data can be modeled as a line. So looking at this data, we can see that there's a positive correlation. So I'm going to go ahead and just sketch in a line here. And I'm not going to go through any specific points. I'm just going to use my straight edge and sketch it in so that there's about the same number of points above the line as there are below it, touching or being as close to as many points as I can. Okay, so I can see that there is a positive correlation. So then I drew my line that appears to fit most of the points in the scatter plot closely. And the next thing I have to do is find the slope. Okay, now again, I don't have specific points. I would have to look at my graph and say, all right, it looks like on my line of best fit, I have the point, and we'll use the points that they actually give us here. But just looking at my line, I would use this point on my line and I don't know, another good one, maybe this point right here. So to me, it looks like 1, 500 would be a good point and 4, 600 would be a good point. Okay, but we're going to use the points that they give us just so that we're all on the same page. So 1, 493, yeah, that looks like it might be on my line. And 5, 621, pretty close to what I have on my line. So again, notice that these points are not actual data set points. Like in 1, my data shows a point of 1, 497, but my line has a point of 1, 493. And in my data, I have 5, 621, and it looks like that one actually is on my line, but it doesn't have to be. Okay, so now I'm going to use my formula for slope to actually calculate the slope of the line I just sketched in. So my slope is y2 minus y1 divided by x2 minus x1. I'm going to call this the first point and this the second point. So my y2 is 621, my y1 is 493, my x2 is 5, and my y2 is 1. When I take 621 minus 493, I get 128 divided by 5 minus 1, which is 4. And I get a slope of 32. That's the slope of my line of best fit. So you can pause the video if you still need more time to work. But I'm going to look at now writing it into an equation of a line. So it says find the y-intercept of the line, use 0.5621. So again, you can use point slope form or you can use slope intercept form. Here we're going to use slope intercept form. So I have my slope, that's 32. So I'm going to substitute 32 in for m. And it says to use this 0.5621. That's my x and my y. So I'm going to substitute 5 in for x and 621 for y. So I get 621 is equal to 32 times 5 plus b. Now I need to solve for b. And I get 621 is equal to 160 plus b. I'm going to subtract 621 from both. I'm going to subtract 160 from both sides to solve for, and I get b is equal to 461. Now that I have my y-intercept and I have my slope, I can write an equation of my line. And my equation is y equals my slope, which is 32, times x plus my y-intercept, which is 461. So the equation of this line is the model I'm going to use to predict the average attendance for varsity basketball games in the future. So I can use the function y equals 32x plus 461, where x is the number of years since 2000. All right, try the checkpoint on your own. So you can pause this video while you work and you can unpause for the solution. So here's my scatter plot, and I can see that as my x values are increasing, my y values are increasing. So therefore, it's a positive correlation with the data. All right, and then let's look at the second practice problem, or the second checkpoint problem. And here we're writing an equation that models y as a function of x. The first thing that we need to do, if you haven't already done this, is to make a scatter plot. So I'm going to plot all of these data points. When you make a graph for your scatter plot, use a scale that makes sense. So I started at 60 and then went up by 5s. I'm not obviously going to go up by 1s. That would be such a gigantic graph. If you use a different scale than 1, though, just make sure that you note that on your graph. So once I have my scale, I'm going to draw my line of best fit, and then I'm going to write an equation for that line. So here's what my line looks like, and I'm just going to pick a couple points that are on this line. I'm going to pick this point right here because it looks like that was one of my given points. So that is point 592. And then I'm just going to pick this point because it looks like it's right on 275. Now I have to find my slope and my y-intercept so I can write my equation. So here I can see that my slope is approximately 5.7. In a problem like this, it's okay to use decimals for the slope because you're estimating. Okay, so the decimal is already a rounded number. We don't know the exact slope of this line because we're sketching it out and we're drawing a line of best fit. So it's okay in this case to use a decimal for the slope. And then next I can look at finding the y-intercept. And here, if I look at my graph, the y-intercept looks like it's about 63, maybe 64. So when I solve, that's about what I should get. And when I solved for b, I got 63.6. So now I can write my equation. And I'm going to write it in slope-intercept form, y equals mx plus b. And I get y equals 5.7x plus 63.6. Please jot down any question or notes that you have, and we can discuss them when I see you in class. Thank you.